Well, good evening, everyone. I hope you're well. I hope you're enjoying the sun. It's sunny for once, even in Swansea, which is unbelievable. But anyway, let's go on with today. What are we doing today, for starters? Well, we are making a dumb phone. It's like a smartphone, but the opposite of a dumb phone. No, sorry. It's like a smartphone, but the opposite. Basically, it's a really simple, stupid phone. And all it can do is it can write out some numbers and it can pretend to call. It can't actually call anything, mostly because we're going to be simulating this, but also because if you were to set up a SIM card and set up your own device unlicensed, then Ofcom, the people who make sure all the telephone networks in the UK are legal, well, they come and beat you up. So we're going to be doing something close to a phone. Not a perfect phone, but close. And the first stage is, well, we're going to be using the Arduino for this. So if you go ahead to tinkercad.com, I'm sending a link in chat now. There you are. If you go to tinkercad.com and type in this lovely long class code, then that should give you access to, well, where we need to go, which is, it should allow you to get access to the simulator. Is that working better? Yep. There we are. There's also, this is a slightly involved process today, so if you ever get lost or left behind or stuck, or you are just a little bit impatient and you want to go in front of me, then you can also go down to this link I've got in the bottom right hand corner, bit.ly/tc-dumbphone, and that will take you to a PDF that basically goes through it for you. So if you get lost or left behind, it'll go through that. And I'll try and mention the steps used in that PDF, just in case you still want to follow along and get lost. Anyway, enough of me blabbering. Let's actually go and do something. So, tinkercad.com. Now, once you've logged in, oh yes, I should explain how to log in, silly me. Now, when you type in the class code, it'll ask you for a username, or a nickname it says. Now I've created about 50 nicknames. You need to pick one of these nicknames. It's just the word Technocamps followed by a number, and you'll need to try and find one that isn't used by someone else. If it's being used by someone else, it'll tell you off, but just Technocamps and a number. So someone might have, I don't know, Technocamps 11, and that should allow you to sign in. If you're following along afterwards, or if for whatever reason the class code doesn't work, then luckily Tinkercad will let you create a free account, and you don't need to go for all this class code gubbins. You can just use your own account and it saves stuff automatically, and there's no danger of losing any of your work. Anyway, where was I? Oh yeah, back to the beginning. When you first sign in, you should get a page like this, and we want to go ahead and create a circuit. And it shows you here all the circuits that it has. Why is that still loading? Oh no. Hope my internet hasn't gone again. Oh well, let's just create a new circuit. Ooh, well, this is a fine how do you do. You're gonna load for me today. If in doubt, refresh. Okay, whilst I'm sorting this out, talk amongst yourselves, grab a nice cup of tea, maybe a slice of cake, and I'll be back in a second when hopefully I'll fix this. See you in a bit. all's good. I'm back. I hope. Still loading, but I think we're there. I gotta have words with my my internet provider. I don't know. They must see me coming. They must think, "Ooh, Thursdays. Let's slow his internet right down." Anyway, we're in. So, if you've not used Tinkercad before, you might see that your circuit has been given a really randomly generated name. Mighty Go-Go Jargub. No idea what that means, but we'll live with it. Is anything gonna work for me today? Come on. Full screen. There we are. Ugh, what a palaver, whatever. Anyway, go ahead, and the first thing you want to do is you see this box over here in the top right labelled components. We want to change that from basic components to all components because we're experts. We're going to have access to the best components we can find. So, click components, click all, and you've got all the components you need. And, well, what do we need? Well, we need an Arduino Uno. So I'm going to type that in, Arduino. And we've got an Arduino Uno. Click it once, move it into the build area, click it again to drop it. If I want to rotate something, which is quite good for when you're working with things that have, the right different orientations, you can click it, and you can use this rotate button in the top right hand corner, or you can press R on your keyboard. I'm going to put it in that orientation. This bit here, the USB cable, I'm going to have facing up towards the sky. Right, we got our Arduino. What else do we need? Well, we're going to need a breadboard. So I'm going to type in breadboard. And we've got 3 breadboards to choose from. I'm going to go for breadboard small. Let's drag it in. Now, before I go on, I need to explain a little bit about a breadboard. A breadboard is a place where you can prototype circuits. You don't have to get out a soldering iron. And basically the way it works is every row of 5 holes is connected together. So these are connected. This one's connected, but it's not. These two are not connected together. They're 2 separate lines of connection. As of these, that one's going to be another line of connection, and so on and so on. I was just drawing wires to illustrate things there. You don't need to draw any wires, they're already connected. And the way it works is it has a little sort of line of conductive metal underneath the plastic, and they all connect together. That's the rows. Now we've got these 2 columns. We've got the negative line and we've got the positive line. So the negative line's all connected together and the positive line's all connected together. And that's essentially all you need. Well, that's your breadboard. What else do we need? Well, we're going to make a phone, but we're going to make a stupid phone. So we're not going to get a nice, fancy, capacitive touchscreen on the go. We're going to get the most basic screen we can find. And for that, we're going to use a liquid crystal display. So in the search bar, type in LCD, and you should find can't talk today. You should find this LCD 16 by 2. I'm just going to sort of drop that in there somewhere. That's our screen, and it's tiny. What else do we need? Well, what use is a phone without something to type in numbers? So we're going to use a keypad, and we've got this keypad 4x4. That's a bit larger, but it's got everything we need on there. Let's just move that down a tad. Let's make everything a bit neat. It gives plenty of space between them. we need two more things. We need a piezo speaker. This is a horrible, tinny, buzzy speaker that makes a horrible, nasty noise, but we're going to use that anyway. Let me just rotate that around a bit. And finally, we're going to need a resistor. So we've got one resistor. I'm just going to plonk it there. And we need to change the resistance of it. At the moment, it is, when you click on it, it comes up, it's saying it's 1 kilo ohm. Now, kilo ohm is too high a resistance for us. We want it as just ohms. And we don't want 1 ohm, we want 220 ohms. There we are. So change your resistor to 220 ohms. And, well, we're pretty good to go. Let's start wiring things up. Now, the very first thing we should probably do is wire up the breadboard. What's the point in using a breadboard to test a circuit if your breadboard's got no power? So if you grab your Arduino and zoom in on it, on the left hand side you should find we've got a 5V terminal and a ground terminal. That's what GND stands for, ground. The 5V's going to be our positive and the ground's going to be our negative. And they're going to, well, provide power. So let's start with the 5V. I'm going to click on it and that's going to start drawing a wire. Now, if you end up getting a tangle like I'm doing now as a demonstration, you can always press backspace. Just press backspace and it undoes the last click you did. And we're going to be working with lots of wires today, so it's a good idea to get into practice the idea of making these wires nice and neat. So whenever I move my mouse in line with another point, see it draws a long blue line? That means that it's snapped to the right place. Now let me zoom out and draw this a bit better. I'm going to go from 5V. It doesn't matter if wires cross. Actually, I don't want that joint there, so I'm going to press backspace on that. And I can drag each of these points just to make it a little bit nicer. Now, traditional, when it comes from positive, it's usually a red wire. Not always. Sometimes in some really cheap, nasty electronics, you find that they've used whatever colour wire they had to hand. But we like to make quality products here on Technocamps, so we're going to use the proper colouring. We're going to use a red wire. Let's connect up the ground now. So find the ground. Draw it around and plonk it in the negative terminal of the breadboard. And of course, tradition states that it's black. Notice that I'm putting them into the corner of the breadboard and it's going along the right lines. So that means that the positive now extends all the way to the other end of the breadboard. And that's exactly what we want. So the next step is to actually get our screen up and running. Well, I say up and running, we need to actually connect to it first. And rather than just have a mess of wires everywhere, I'm going to stick it in the breadboard. So I'm going to grab the screen, just click to grab it, and I'm going to drag it. And when you drag it over the breadboard, you should feel it sort of snap into the holes. It doesn't matter really where we put it on the breadboard, as long as we've got some space to work with. So I'm going to just sort of stick mine... Oh, sorry, let me clarify. It should go in the rows, not... Sorry, it should go in these ones here and not the plus or minus rail. So I want to go over the plus or minus rail and plug into these ones here. And that means I can start wiring it up. So we're going to go from right to left on this LCD, we can see we've got these pins on the LCD. We've got LED, LED, DB7, DB6, DB5, DB4, DB3, DB2, DB1, DB0, E, RW, RS, VO, VCC, and ground. And we're going to connect up most of these. And we're going to start on the right. So the right part is the negative power, the ground for the backlight of the LCD. We're making a slightly fancy phone. We want it to light up. I mean, back in the very early days of mobile phones, they didn't have backlights. And so if you wanted to read text, you had to make sure the sun wasn't too bright and it was just enough to read. It was a mess. So let's connect this rightmost negative terminal up to the negative ground rail. But if we do that straight away, then that's going to cause a problem, because we're supplying too much voltage for the LCD and we don't want to blow it up. So I'm going to use this resistor that I've set to 220 ohms, and I'm going to put it bridging the gap between the gap in the breadboard. And then I'm going to connect it to I'm going to connect the other end of the resistor to the negative terminal. So just to actually, let's carry on. I've got the negative side. Now I need to get the positive. So I need to go from the positive rail and provide power to the next bit along of the LCD. Let's call that red for tradition. Let's double check. Let's trace this circuit and see if everything's tickety-boo. So we start with our Arduino. 5 volts comes out of the 5 volt terminal, goes along this red wire, carries on along, and it goes into the positive rail of the breadboard. Now it goes underneath all of these holes, and it hits this wire here. It travels along this wire, and then it dips inside the breadboard. And it travels underneath these holes and up into the LCD, and it gives the LCD a nice backlight. Then it comes out of the backlight into the negative terminal of the LCD, into the breadboard, through the resistor, through the breadboard, and then through this wire into the negative terminal, which then goes back to the ground on the Arduino. I'm not going to go through that every time, but you should be making considerations to is the circuit complete. Let's start actually wiring up the data buses of the LCD. This is what transfers data and characters and letters to the screen. So DB7, it comes out of the breadboard. One problem with this is you can't scroll whilst you've got a wire attached. There we go. So I'm going to go from DB7 up, round, and DB7 plugs directly into pin 8 of the Arduino. Let me just zoom in on that. We've got pin 8 on the Arduino plugged into DB7 of the screen. And we're going to go up a little bit for pins DB6, DB5 and DB4. So DB6 comes up, round, I've forgotten. Every blooming time, I always forget that you can't scroll whilst drawing the wire. It's very annoying. Sorry, DB6 comes up, down, around, and plugs into pin 9 of the Arduino. DB5 plugs into pin 10 of the Arduino, and DB4 plugs into pin 11. Now, I could go around making all these wires nice and neat, and I should really, but I just don't have the time. So I'm just going to kind of leave them as is. Oh, someone's asked on Twitch, why add a resistor? If I get rid of this resistor and connect up the black light and press start simulation, we can see that it blows up the LCD. And that's all to do with the ampage. So we're giving it 23.7 kiloamps, which I don't think that's even possible, is it? That's massive. Anyway, it blows up the LCD. So we do need that resistor in the way. I'm not saying Tinkercad is a perfect simulation, but yeah, it doesn't harm. It doesn't harm to have a resistor in the way. Anyway, sorry, where was I? We've added we've added wires between DB7, DB6, DB5 and DB4. And we're not going to do DB3 downwards because we don't need those. We're going to start doing E. So I'm going to skip over DB3, skip over DB2, skip over DB1, skip over DB0, and the next wire I'm going to draw is from E. So make sure you're drawing from the E line. And the E line, well, that needs to go into pin 12 of the Arduino. So I'm going to go up. Oh, it hurts me to see wires this messy, but I mean, if I had, you know, a couple of hours to myself, I'd just spend all the time fixing these wires, but I just don't have the time. Let's colour that wire purple so we can see that it's different. Okay, back into the LCD pins. And we've got the pin RW. That's the pin that we tell the LCD whether we want to write to or not write to the LCD. And so we always want to write to it. Why wouldn't we? So to make sure that you can always write to it, I'm going to connect RW. And I'm going to connect it straight to the negative rail. RW to negative rail. And let's give it our customary black. And that means we can always write to the LCD. Next we've got RS. Now RS needs to go into pin 13 of the Arduino. So I'm going to grab that. Oh, it's getting a bit like spaghetti in here. So RS to pin 13. Let's make that orange for some reason. I don't know. I like orange. And that should be mostly it for the wires going between the LCD and the Arduino. The rest of the wires just go between the LCD and the breadboard. So the V0 pin of the LCD, that needs to go to the negative rail. So negative rail, V0, let's give it our customary black. VCC is how we give the LCD its power. So I'm going to connect one on there and I'm going to connect it to the positive rail. So we're giving VCC 5 volts. There we are. And finally, this is the last wire in the LCD, I promise. We're going to draw a line from ground to the negative rail. So ground to ground. Give it our customary black. Right, let's just do a quick recap, make sure everyone's on the same board. Remember that if you're stuck or if you're a bit behind, you can check out bit.ly/. /tc-dumbphone, and you can see that link in the bottom right, and that'll go through it all nice and clearly for you. But if not, we should have going from right to left, we should have a resistor and a wire going to the negative line, one from positive to LED, 4 data cables, and they are all going to the Arduino, a gap of 4, then we've got a cable going from E to the Arduino, a cable going from RW to the negative rail, a wire called from RS to the Arduino, negative rail to V0, positive rail to VCC, and negative rail to ground. And that's it. That's everything that our LCD needs, except the code and, of course, the keypad. But that's every wire the LCD needs. Let's see if anything happens when we press Start Simulation. And there we are. It lights up. Of course, there's nothing on the LCD, but it lights up, which means we've done something right. And again, if it doesn't work out, either ask me or check the link in the bottom right hand corner. Anyway, let's stop that simulation. And that's it. Well, let's do the keypad first. I want to save all the code to the end. Now the keypad is a slightly easier fare. If we look at the bottom of the keypad, we've got 8 terminals. And when we hover over each terminal, it gives us the name of that terminal. So we've got row 1, row 2, row 3, row 4, column 1, column 2, column 3, column 4. And, I've just noticed there's a mistake in the PDF where it says row 1 to pin 7, row 1 to pin 7 twice. It should be columns for the second one. I will fix it after I finish, but when you're following along, we have row 1, and row 1 goes straight to pin 7 of the Arduino. I forget you can't scroll when you've got a wire. There we are. Row 1 goes to pin 7. Let's pick a nice colour for that wire. I'm going to make it blue. Row 2 goes to pin 6. Row 3 goes to pin 5. Stop neating the wires. There we go. And row 4 goes to pin 4. So just to clarify, row 1 to pin 7, row 2 to pin 6, row 3 to pin 5, and row 4 to pin 4. And now we do exactly the same with the columns, just for different pins. So we have column 1 to pin 3, column 2 to pin 2. Oh, such ugly wires. Stop it. There we are. Column 3 to pin 1. And column 4 to pin 0. Let's leave them green. So column 1 to pin 3, column 2 to pin 2, column 3 to pin 1, and column 4 to pin 0. And that's everything we need, really. let's do the code. So click code, and we're going to graduate from blocks today. Well, mostly because blocks can't actually use the LCD, but we're going to go to text mode. So in the code panel, you can find where it says blocks at the top, and if you click this drop-down menu, you can decide whether you're blocks, blocks and text, or text. We want to go text only, so click text, and it gives you a nice warning. It's all very threatening. Your work will be destroyed. The planet will blow up. Let's just click continue. And it's given us some junk in there already. We kind of want to get rid of that junk. So the first line, if you look on line 3, you want to delete that line. We want to keep void setup as it is. Notice that void setup has a round bracket and a close bracket afterwards. Let me zoom in on that a little. There we are. And then it has a curly bracket followed by a closed curly bracket. We want to leave void setup just like that. Void loop, well, we want to delete every line from 8 to 11. So void loop should look like that. We're just getting rid of the junk that Tinkercad has automatically put in there for us. And now we can get on with our coding. And the first thing we need to do is tell the Arduino that we're going to use an LCD and we're going to use a keypad. And to do that, if you look along the top, you can find 3 buttons. We've got what looks like a download arrow, what looks like a folder, and what looks like a beetle. We want the folder option, which is the libraries. That's the middle button. And it gives us all the libraries that we can import into Arduino to give it extra functionality. So we've got one for servos, we've got one for SD cards, we've got one for stepper motors. We want to include the one for liquid crystal. So I'm going to find liquid crystal in this list and I'm going to click include. And you can see that it's written a line of code for us at the top which says $, include liquid crystal.h. We want to do exactly the same for keypads, so click on the folder button and we can find one called keypad and we want to include keypad. So now we've got 2 nice bits of code at the top already written for us that make sure we can use the keypad as we want to, and the LCD. So, what are we going to do first? Well, the very first thing is we need to tell our LCD what pins it's going to be using. So, in between include liquid crystal and void setup, so above void setup, I need to type out liquid crystal, making sure I get the capital L and the capital C. Liquid crystal. Now I need to tell it what I'm using. I'm using an LCD. So I type in LCD. And now I need to tell the LCD what pins it's going to be using. So open bracket. And if we look over on our Arduino, our LCD is using pins 13, 12, 11, 10, 9 and 8. So I need to write those down. So 13, 12, 11, 10, 9, 8. That's the pins it's using. I'm going to finish that off with a rounded bracket. And because Arduino is using a variant of C, C is a very old programming language. C ends its C and C++ end their sentences, so to speak, with a semicolon. So I've typed in liquid crystal LCD 13, 12, 11, 10, 9, 8, and after the closing bracket, 1 semicolon. And we're good to go. That's our first line of code. Now let's make things. Let's do the keypad next. Now, you can have keypads of all different sizes. You can have keypads that have got thousands of buttons on, like the keypad on a lift, or you could have a keypad that has 2 buttons on. Ours has 16, so we need to list the number of rows and the number of columns. And for that, I'm going to need a variable. Let's create a variable. So, we need to make a special type of variable. We need to make a constant. A constant is slightly different from a variable in that a constant doesn't change. Its value stays constant. Whereas a variable, its value is variable. It can change. So to declare a constant, I need to type in const. C-O-N-S-T. And what type of constant is it? Well, we're going to store it as just 1 byte. Just a byte. So const byte. B-Y-T-E. And now we need to give our constant a name, and this is going to be number of rows. So let's give it a sensible name like num rows. And I need to say what it's equal to. So equals, how many rows do we have in our keypad? Let's get it up. Where are you? Somewhere. Oh, the joys of working with a tiny screen. Well, we've got 4 rows and 4 columns. So the number of rows equals 4. This is C++, so end it with a semicolon. And now we need to make another constant just for columns. So const byte num cols. Cols being short for columns. And how many columns do we have? We have 4 columns. End it with a semicolon. So we've got the number of columns and we've got the number of rows. Now we need to say which row is connected to which pin and which column is connected to which pin. This is a slightly more tricky one. It's not constant because we could change this if we wanted to. If, for example, you wanted to create, I don't know, a phone that scrambled the keyboard into random orders every time you dialed a number. It would be very impractical, but it would be secure. But we're not going to do that. We're just going to type in byte, because we're using bytes. And we need to say what the pins are for the rows. So let's make a way of storing that. Let's call them row pins. Row pins. Open square bracket. And how many rows do we have? We have 4. But rather than writing in 4, we can just type in num rows. Close square bracket. I don't just type in 4 there, because if I did, I'd have to, as soon as I had a larger keypad, I'd have to change those numbers everywhere in the code, and that would just be boring and tedious. We don't want that. So row, byte, row pins, square bracket, num rows, close square bracket, equals, open square bracket, and this is where you start listing the pins which the keypad is plugged into. So let me maneuver my tiny window. Now the rows, which were on the blue lines, are plugged into 7, 6, 5 and 4, so let's write those out. 7, 6, 5, 4. And I put a comma between each one. And a close square bracket. And of course this is the end of a sentence, so semicolon. So let me just recap. Byte, row pins, open square bracket. Oh, what have I done? Oh, bums. Can I undo that? No, I can't undo that. Row pins. This is why it's always important to check your code, because all you have to do is lean on your mouse and suddenly everything's gone mad. You got paragraphs up at the top, you got declarations down at the bottom, it's all gone mad. So, sorry, where was I? Let me clarify. Row pins, open square bracket, num rows, close square bracket, equals, open square bracket, 7, 6, 5, 4, close square bracket, semicolon. And we need to do the same for the pins that the columns are attached to. So I'm going to declare a byte. I'm going to be very imaginative and really stretch the powers of creativity, and I'm going to call this col pins. For column pins. Say what you will about programmers, but yeah, I don't know where I was going with that. This is working with columns, so we're going to use num cols, and we're going to have a close square bracket, and we need to say what pins that the columns are attached to. So equals open square bracket 3, 2, 1, 0, close square bracket, semicolon. Again, if you'll find yourself a bit behind, I've got the entire code written out in full, available at a link in the bottom right hand corner, but otherwise, let's press on. So, that's all well and good, but my Arduino still doesn't know what button on the keypad corresponds to what symbol, what letter. If I close the code momentarily, we can look at the keypad. We can see that our keypad has 1, 2, 3, A, 4, 5, 6, B, 7, 8, 9, C, star, 0, pound symbol. It's called the pound symbol. I get very annoyed when people call it a hashtag. I know it's a hashtag. I'm just old. And then a D. Let's open up code again. We need to actually tell our Arduino what those symbols are. So each of those symbols is one letter. So to show one letter, we're going to use a new data type called a char, which stands for character. So every letter or number is known as a character. So char. And this is going to be a map of all the keys on that keypad. So I'm going to be very imaginative and call this key map. And I need to say how many rows does it have, how many columns. And so rather than typing in 4, I'm going to use square bracket num rows, close square bracket. Oh, I've got a little small error here. I don't know whether you can spot it, but I've added in an extra R. That would cause an error when you press run simulation. So I'm going to delete that. It's always good to just double check what you're writing as you're going along, just in case you find a mistake like that. We got the number of rows, now we need the number of columns. So open square bracket, num cols, close square bracket. What does this equal? Well, I'm going to tell it what it equals, so it's going to equal, and on a new line, I'm going to open a curly bracket, this time not a square bracket, a curly bracket. And this is where I write out every single row of the, every single row of the keypad. So open a curly bracket, And if we look at the first row, it's 1, 2, 3, A. So this is how I'm going to do it. We're going to use apostrophes rather than our usual speech marks. We're going to write apostrophe 1, close apostrophe, comma. So remember that pattern. Apostrophe, letter, apostrophe, comma. Apostrophe, letter, apostrophe, comma. So apostrophe 2, apostrophe, comma. Apostrophe 3, apostrophe, comma. Apostrophe A, and notice it's a capital A. Apostrophe, but no comma, because this is the end of the first row. A comma always shows that there's going to be more afterwards, but there is nothing more afterwards on the first row. It just ends there. So I'm going to close that with a closed curly bracket. And we've got the first row. Now to add the second row, well, I'm adding more stuff onto the end of this. So I'm going to put a comma after that. I don't know whether you can hear that, but it's certainly distracting to me. I can hear my neighbours having a nice chat about the weather. So sorry if you can hear that. That's one of the joys of working from home, just constant chat about the weather from neighbours. Anyway, where was I? Yeah, so we're on the next line. I'm going to start with a semicolon, and we're going to repeat our pattern, but this time it's for the second row. So apostrophe, letter, apostrophe, comma, space. Apostrophe, letter, which is 5, apostrophe, comma, apostrophe 6, apostrophe, comma, apostrophe B, apostrophe, and no comma, because this is the end of the row. So we show the end of row with a closed semicolon, closed curly bracket, and we move on to the next row with a comma, open curly bracket, apostrophe 7, apostrophe, comma, apostrophe 8, apostrophe, comma, apostrophe 9, apostrophe, comma, apostrophe C, apostrophe, no comma, we end with a curly bracket, comma, next final row, and then we can move on from this. It's very tedious. Open the semicolon, apostrophe, asterisk, apostrophe, comma, apostrophe 0, apostrophe, comma, apostrophe pound symbol, which I can never remember how to get on this keyboard. 1 second. Ah, there we are. It was hiding above the enter key. Sorry, pound symbol, comma, and finally the very last one, apostrophe D, apostrophe. End with a semicolon, and there are no more rows, so we don't need a comma after the semicolon, but we do need to complete this open semicolon at the top here. So after I've written 4 rows, I need to end it with a closed semicolon. Altogether, in these few lines of code, you should have 20 curly brackets. I keep calling them semicolons. That's very confusing. You should have 20 curly brackets. Again, if you're a little bit stuck, do check on that link in the bottom right hand corner. Right. One last thing, we need to declare one last variable that's going to store which column of the LCD we're working in. So int, this is going to be whatever is the current column, so I'm going to call it current col. And the first column is 0, so equals 0, semicolon. Oh, I tell a lie, we forgot to do one thing. We forgot to actually set up the keypad as a keypad. So, I need to have keypad. Notice it has no Y, which is a misspelling. Let me start that again. Reverse. I have keypad with a capital K, K-E-Y-P-A-D. I need to give my keypad a name. Let's give it something imaginative. Actually, let's not. We're computer scientists. My keypad. Can't just call it keypad, but I can call it my keypad. So what does my keypad do? Well, my keypad is or equals a keypad. So keypad, my keypad equals keypad. You're going to get sick of the word keypad by the end of this. Keypad, my keypad equals keypad, open bracket. And this is where we need to apply that key map that we spent ages writing out to the keypad. We need to sort of overlay them on top. So keypad, open round bracket, make key map. So in make keypad, make key map, K is the only capital in that. Make key map, open round bracket. What key map do we have? Well, we've already created a key map called key map. So make key map, close round bracket, comma. Now we need to tell it what pins are being used for the rows. So remember that we store this variable that's called row pins, a list of all the pins that have rows connected to. So row pins. And as you can imagine, col pins comes next. I'm putting a comma between all of these. What do we have afterwards? Well, we need to say how many rows and how many columns. So num rows, comma, num cols for columns. And I end this mammoth line of code with a close round bracket. And as it's a sentence, a semicolon. So keypad, my keypad, let me get that taking up the whole screen. Keypad, my keypad equals keypad, make key map, row pins, col pins, num rows, num cols, semicolon. I've spotted another mistake I've made. I've forgotten a semicolon somewhere. So if you find your key map, your char key map, remember where you wrote all those rows, needs a semicolon at the end. So for me, that's line 20. It might be a different line for you, but it's around about there. Whew. That's all over. Somewhat. We need to actually write to our LCD. So I'm going to go into void setup. And here I can do LCD dot begin. Now we need to tell the LCD how big it is, and this is a 16 by 2 LCD, so 16,2, close round bracket, end with a semicolon, which I always forget. So LCD.begin 16,2, and this is where we can actually write something to the LCD. I can say LCD.print. Now, we're making a mobile phone, so let's have it say enter phone number or enter number. So inside lcd.print, inside the brackets, I'm going to have a semicolon. That's not a semicolon, that's a semicolon. That's not even... Oh, my brain today. Sorry, speech mark. I mean speech mark, not semicolon. They both begin with S, in my defence. Speech mark. Enter number. close the speech mark, and let's end that with a semicolon, because we have to. And let's click off code for now, and see if everything we've written so far works. Let's click Start Simulation. And keep fingers crossed. Oh no, we've got an error. What error is this? Well, what are you talking about? Why are you doing this to me, you numpty? Byte. Const byte. Huh. Const byte. This is a new one on me, I have to say that for sure. What are you talking about? What are you talking about? I can't see anything that's out of the ordinary. That's got a semicolon, that's got a semicolon. Byte, row pins, num rows. Nothing's spelled wrong so far. Line 11, what's up with line 11? I've got no... I'm just going to try something. I'm just going to try making these not be constants. See if that fixes it. Don't know why it would, but when you're debugging things, you just try things, see what happens. No, that just made things worse. Why are you being a bum to me? No worry, as is always the best, I've got a backup. Let's just hope the backup loads. There we are. This is the one I made first of all. If it's going to load. I certainly hope it does. There we are. Oh, no, it's thinking about it. There we are. Ah, I know why. Oh, I'm an idiot. Okay, I figured it out. So, let me zoom in on that. So the reason mine was throwing an error is I'd used the wrong type of bracket. So in the byte row pins, num rows equals, I use square brackets. It shouldn't have been square brackets. It should have been curly brackets. So find your row pins and col pins lines and double check whether they've got square brackets or curly brackets. They should be curly brackets. Oh, I'm relieved. I thought I was a real numpty then. Anyway, it's alright, we are very close to the end anyway. This is the one I was building as a test. As you can see, I actually spent time making the wires nice and neat because I have to. And this is what should have happened without the error. When I click Start Simulation, it shows me enter number. Let's finish off the rest of the code. Let me just wipe this out. I've extended a little bit beyond my usual finishing time of 5:30. I hope that's not too much of a problem for you. You can always come back and watch this when it's, not live, when it's on repeat. So sorry for running late, but that error really threw me. Wasn't expecting that. Anyway, so we've now got it printing, enter number. Now I need to actually, do something when I type on the keypad. So let's do that. Let's say LCD dot. What do I need to do? Well, I need to move the cursor on the LCD. The cursor like this one I've got blinking away here. I need to move it down a row. So I'm going to set cursor, making sure it's a capital C. And what am I going to set it to? Well, I'm going to set it to whatever column I'm currently typing in. So remember that we had this variable called current col for current column. So current col. It's going to start typing in current column, and it's going to start typing on row 1. So just typing 1 after that. And a rounded bracket and a semicolon. Now, interestingly, row 1 is the second row down. In computer science, we always count from 0. So lcd.set cursor, current col, comma 1. Now, on a couple of lines afterwards, this is where I can actually start asking my keypad if there's any key that is pressed. And to say whether a key has been pressed, well, we need to store that. So I'm going to store that in a char. So type it out, char. And this is going to be the key pressed, so I need to give it a name. Let's call it, let's really flex that creativity. Let's call it key pressed. And this is going to store whichever key is being pressed by the keypad. So key pressed equals, we called our keypad my keypad. So my keypad dot get key. And notice that the K is capitalized for get key. Open bracket, close bracket, semicolon. I'll just leave that line up for a bit. Char key pressed equals my keypad dot get key. Okay, so we've now stored whatever the keypad is pressing. How do we tell if a key is being pressed? Well, we need to read the variable key pressed and see what it's equal to. And if it's equal to absolutely nothing, we should do nothing. But if it's not nothing, as in if it's something, then we should do all of our logic. So we need to tell whether our key pressed is empty or not. So if open bracket, because this is an if statement, key pressed. Now, how do we say not equal to? It's a funny bit of logic, but if we want something, when we say something's equal to something, we use two equals together. But when we say not equal to something, we use exclamation mark equals. Sorry, that's neighbours closing their door. Exclamation mark equals. If key pressed is not equal to no underscore key. And that's all in capitals. Now, no underscore key stands for no key is pressed. So, it's a little bit of a brain puzzle, but if the key that is being pressed is not equal to no key being pressed, i.e. if any key is being pressed. Let's open up our if statement. Let's open it with a semicolon, not a semicolon, with a curly bracket. And then on the next line, we can do whatever we like. And well, for this, let's say, yeah, let's type out. Let's type it onto the screen. So lcd.print. Who's that at the door? No one. Oh, it's all busy today. I reckon it's the sunshine. It's getting everyone out and about. Anyway, lcd.print. And what are we printing? Well, we're printing the key that is pressed. So key pressed. And close it with a rounded bracket and finish off that sentence with a semicolon. Now, we've typed one number, so we need to move it on a little bit. We need to carry it on. And we keep typing it in whatever's the current column. So we need to make the current column increase. So current col equals current col plus 1 semicolon. We're adding on to the current column. Right, let's try it out. Let's finish off this if statement first, because if we don't, we're going to cause an error. Let's finish it off with a closed curly bracket. So void loop lcd.setCursor current col, 1 char key pressed equals myKeypad.getKey. If key pressed is not equal to no key, then we print the key pressed onto the LCD and we move the cursor along a bit. Let's try that. Let's see what happens. Let's press start simulation. Wait for it to load, which is taking a worryingly long time. There we are. Enter number. Now, with the simulator, it can be a little bit laggy, so you might need to very firmly press the numbers on the keypad. Let's click 1, and 1 appears on our phone screen. Let's click 3, 4, 2, 8, 6, 7, 2, come on, there we are, A, B, and so on. And I don't know what phone number has A or B in it, but it's there. Maybe now that you know how to print to the screen and how to control the keypad, you can add maybe a phone game. You could add lots of different menus and features, write memos, all sorts. Well, actually, it'd be a bit hard to write memos with only using A, B, C, and D, but you get my picture. This is room to expand. You can actually very easily write a calculator using this. You can write a calculator that uses you can have A for add, D for divide, asterisk for times, C for carrots, I don't know. And in fact, one way that you could expand on this is you can make it like a real telephone. You'll remember that I asked you to get a piezo speaker out. Well, if you get your piezo speaker and you plug the negative lead, which is visible when you hover over it, into the ground, and the positive lead into the A0 port of your Arduino, you can actually get it to make some noise. If you go to code, underneath lcd.print key pressed, we can have tone. Tone is how you get it to make a noise. You say what pin you want the tone to be made on. Well, it's been made on A0. What pitch do you want the tone to be played? Let's say 500. And how long do you want it to be played for in milliseconds? We don't want very long because it's a horrible sound. Let's say 50 milliseconds. Close the bracket. Close the semicolon. And let's start the simulation. We've got the speaker there. If you're of a nervous disposition and you don't really like horrible sounds, you might want to mute things now, but Ow! That hurt. Ow. That's very loud in my ears. I do apologise, but we've added a speaker. And I'll be honest, this isn't a phone. It's just a fun little keypad. You could actually have it so you could maybe, I don't know, set a password on your door. By adding a servo to this, you could have it so that if someone types in the right password, then the servo activates, which opens the door or locks the door or things like that. And you can do all sorts of interesting things with this. And part of the interesting thing about the speaker is that's how phones actually work. What phones do when you type a button on a phone is it sends a tone through the line and into the telephone exchange, and they interpret that tone as a number, and each number has a different tone. So that's how BT, or whoever your telephone exchange is, reads what numbers you're typing in on your phone. And that's where it gets really interesting. Like back in 70s, 80s, there's a very famous case where somebody managed to hack into a telephone exchange by playing the right tone. And the tone was 22,000 hertz. And the way they played that tone was using a plastic toy whistle that came in a packet of cereal. So that's one cool thing about phones. I won't go into details, but I thought I'd show you one that I'd made myself. I always like to test out these circuits in the real. So here's my circuit. Ooh, my camera doesn't like it though. Let's actually test this out a little. Let me plug it in, give it some power. You can see I've got exactly the same stuff as we've been building. We've got an Arduino Uno, we've got a speaker, we've got an LCD screen, and I don't have a keypad, but I do have a load of buttons. Let's test it out. Let's do... And when I press one button, ooh, it pretends to dial. And so on. So you can do some really cool things with this, and well, I hope I've inspired you. And as always, you can request to join our Discord, ask us about, you know, how can I expand on this, how can I make it more interesting. Check back regularly on the Technocamp's website. We have a special folder for anything that's created on the virtual Technoclub streams, and I will be updating that with, well, things like this. I might even give you access to this very circuit yourself, so you could just download it and go rather than have to make it yourself. It's up to you. Don't forget to check out that link there, and I hope you've enjoyed. I hope you had a nice evening, and good night. Wrong button.